Let's begin question 4. A compass is used to draw a sector of radius 6 centimeters and area 11.32 cm square. Determine the angle of the sector in the radian. So let's do a little diagram there. So we have a circle compass used to draw, right? So the radius is 6, so this is 6 centimeters. The angle, well, this angle is what we want to find. Let's call it theta. And the area is 11.32 square centimeters. Right, so you'll recall that area, when the angle is in the radians, is half r square theta. So we have area as 11.32, half, we have r as 6, so half times 6 square times theta. So we now need to find theta, so we can, so this is 11.32, so 6 square is 36, so half of 36, that's 18, so 11.32 is equal to 18 theta, so we divide both sides by 18, so theta is equal to 0.63 radians, so 18 to itself. Let's move on. Calculate the perimeter of the sector. So the perimeter, again the perimeter, distance around, so the perimeter of the sector, so P would be equal to this radius, so that's 6, plus this part, that's 6, plus the area of the arc here, the area of the arc there, so that would be, sorry, the perimeter of the arc distance there, and that's given by r theta. So it's r theta. So it becomes, so perimeter is 12 plus radius is 6 times theta, which is 0.63. So we end up with, yeah, so 6 and 6, that's 12, and so 12, r is 6, theta is 0.63. So it's 12 plus 6.63, which will give us 15.78 centimeters, and I'm giving my answer to 2 decimal places. Next, a right angle triangle XYZ has an angle theta, where sine theta is root 5 over 5. Without evaluating theta, calculate the exact value in third, if applicable, of cos theta. So let's do a sketch of this triangle. So we have a right angle triangle, XYZ. So let's call this angle theta. So we are told that sine theta, so remember sine is opposite over hypotenuse. So root 5 over the hypotenuse, which is 5, opposite over, so sine theta is opposite over hypotenuse. So we can get the adjacent side by Pythagoras theorem. Let me call the adjacent side small x. So using Pythagoras theorem, small x square plus root 5 square should be equal to the hypotenuse square, which is 5 square. So x square plus root 5 square is 5. 5 square is 25. So x square is, so if I subtract both 5 from both sides, x square will be equal to 25 minus 5, which is 20, which means that x is equal to root 20. Right, so this side is actually root 20. So we're asked now to find cos theta. So cos theta, remember cos theta is adjacent. Cos is adjacent over hypotenuse. So cos theta, the adjacent is root 20 over hypotenuse, which is 5. Now they want the answer in third form, so we can rewrite root 20 as, so remember 20, root 20 can be rewritten as rewrite 20 as 4 times 5. So root 20 can be written as root 4 times root 5 all over 5. So cos theta, so root 4, that's 2, and root 5 into root 5, that's 1 over root 5, so 2 over root 5 would be your solution in third form. Next we're asked to find sine 2 theta. So sine 2 theta, a double angle identity. So sine 2 theta is 2 sine theta times cos theta, which is equal to 2. Now sine theta, the question gave us that. Sine theta was root 5 over 5. Sine theta was root 5 over 5. And cos theta was 2 over root 5. So root 5 into itself, that's 1. So we end up with 2 times 2, which is 4. 5 times 1, so the answer there is 4/5. Next we have a proof of a trig identity, so we can start from the right hand side, well, left hand side with more terms. So left hand side, abbreviating, I'm using LHS to represent left hand side, as tan square theta plus 1. Now you recall that tan theta is actually sine theta over cos theta. So tan square would be sine theta over cos theta all square plus 1. So this becomes sine square theta over cos square theta plus 1. So we want to add these two, so let's rewrite the 1 as a fraction over cos square, so I can times numerator by cos square theta. So I rewrite 1 as cos square over cos square, and now I have the same denominator. So this is cos square theta. This is cos square theta. This is also 1 times cos square, that's cos square theta. 1 times cos square, that's cos square theta. And we have sine square theta. So we have a common denominator in cos square, so we can put everything in the numerator over cos square theta. So this is sine square theta plus cos square theta. It's probably the most famous trig identity. Numerator there, that works out to be 1, so 1 over cos square theta, which is what the right hand side is. Alright, 1 over cos square theta. So the left hand side equal to the right hand side. Therefore this proof was quite easily done. Let us move now to question 5. The stationary points of a curve are given as 5, 11 and 2/3 and 3/15. Derive an expression for dy by dx, and of course dy by dx would represent the gradient. So you recall that curve is stationary. Curve is stationary when the gradient dy by dx is equal to 0. So curve is stationary when dy by dx is equal to 0. Alright? Which means that, so remember that, so if you'll note that this occurs when, notice the x values, x equal to 5 and x equal to 3. So if I subtract 5 from both sides, it happens when x minus 5 is equal to 0, and when x minus 3 is equal to 0. So it means that dy by dx would be equal to x minus 5, x minus 3. Alright, and of course we can expand that. We can leave it. So notice when x is 5, dy by dx is 0, because we're told the stationary point there occurs at 5. And when x is 3, dy by dx is also 0. Since 5 and 3 are the x values for when the gradient is 0. Alright, next, determine the nature of the turning points. Determine the nature of the turning points. So to get the nature, we'll need to find the second derivative. So let's find the second derivative. So d2y by dx squared. To get the second derivative, I'll just differentiate dy by dx. I will use a product rule. Alright, a product rule. So differentiate the first bracket. I end up with 1 times x minus 3 plus, and I alternate, differentiate the second bracket. I get 1. I'm left with x minus 5. So this is x minus 3 plus x minus 5. At the x's we get 2x minus 3 minus 5. That's minus 8. So when x is 5, the second derivative d2y by dx squared is equal to 2 times 5 minus 8, replace x with 5, so 2 times 5, 10. 10 minus 8 is equal to 2, which is greater than 0. So therefore, when x is 5, this would be a minimum point. So therefore, the point was what? 5 and 11 2/3, so 5 and 11 2/3 would be a minimum, since the second derivative is greater than 0. When x is, what's the other x value? Other x value is what? 3. When x is 3, second derivative d2y by dx squared is equal to, this time now I'm replacing x with 3, so 2 times 3 minus 8, so that's 6 minus 8, that's negative 2, which is less than 0. So therefore maximum, so the other turning point was what? Was 315. So therefore 315 is a maximum. Next, we're asked to determine the equation of the curve. Now let's remind ourselves what dy by dx was. So dy by dx was equal to x minus 3, x minus 5. If I expand this, this is x squared minus 5x minus 3x. And minus 3 times minus 5, that's positive 15. So dy by dx is x squared minus 8x plus 15. And therefore to get y, so this is dy by dx. So that means to get y, we can integrate. So therefore y would be the integral of dy by dx, which is x cubed over 3 minus 8x squared over 2 plus 15x plus a constant. Actually here we actually integrate. Alright, so integrate dy by dx, we get y. And of course we integrate that with respect to x. Now we need to find the value of c. Now you'll remember that we were told that these 2 points were on the curve. So we can substitute, let's choose 315. So we can substitute 315. Since it lies on the curve, so we can use it to get the value of c. Alright, so we can substitute 315. So we end up with, let's just ignore this for now. In this space. So substitute 315. We end up with, I replace x is 3, y is 15. So we end up with 15 equal to 3 cube over 3 minus, well, 2 into 8 is 4. So it really is minus 4 times 3 square plus 15 times 3 plus c. So 15, now this is 3, this is 9, 27 divided by 3, 3 square is 9 times 4, that's minus 36, 15 times 3, that's 45, plus c, so this is 15, so negative 36 and 45, that's 9, 9, 9, 9, 18, so here c will be 50, subtract 18 from both sides. So c will be negative 3. So therefore, the equation for the curve would be, let me put it here, the equation for the curve, we'll put it in this box here, is y equal x cubed over 3 minus 4x, 2 into 8, that's 4x squared, plus 15x, plus c, and we just found c to be minus 3. So that would be the equation of our curve. Let's move on to part B. So here we are asked to differentiate, let y be equal to the cube root of 2x plus 3 squared. So we can rewrite it like this: 2x plus 3 power of 2/3. So we can apply the chain rule there. Apply the chain rule. The chain rule says dy by dx, and the chain rule says you multiply by the power. So that's 2/3, 2x plus 3. You subtract 1 from the power. So that's 2/3 to the minus 1. 2/3 minus 1, and we differentiate what's in the bracket. Differentiate 2x plus 3, we end up with 2. Alright? So if we can rewrite this, as, well, the 2 times the 2 outside here give us 4, so 4/3, and then 2x plus 3, subtract, so 2/3 minus 1, that's negative 1/3, which we can rewrite, if we want to rewrite, so using indices, so this would be 4 at the top here, and this would be 2x plus 3 to the positive 1/3. And we can also go further and rewrite it as 4, 3, the cube root of 2x plus 3. Alright, so we put the cube root in here, put it in here. Alright, so either this form or this form would work. Question 6, we asked to integrate 3 cos x plus 2 sin x. And we assume it's with respect to x, right? So integrate 3 cos x, we get 3 sin x. Integrate 2 sin x with minus 2 cos x plus our constant. Part B, the trick here would be to rewrite this. So note that root x, so let's rewrite it. So 4, 1, 2, root x is x to the power of 1/2, and we're dividing by x to the power of 1 dx. So before we integrate, let's rewrite it. So 2, now x, so indices, you're dividing, so you can subtract the powers. So this is really x to the power of 1/2 minus 1, which is minus 1/2 dx. Now let's just integrate. So integrate, we add 1 to the power, alright, so add 1 to the power, we get 2x to the power of negative 1/2 plus 1, that's positive 1/2, divide by the new power here, which is, so we're dividing by half. We're doing the limits between 4 and 1. So we can rewrite, so 2 divided by half, that's what, 4. So this is really 4x to the half, evaluating between the limits 4 and 1. So we form 2 brackets. In one bracket we replace x with 4. So it'll be 4. So this is 4 root x. So this is 4 root 4. So 4 root 4. X to the power half is root x, right? So it's 4 root 4 and then minus, so replace x with 1, 4 root 1. Okay, remember x to the half is root x, alright? So this is root x. So 4 root 4 minus 4 root 1. So 4 root 4 is 2. So 4 times 2, that's 8. Root 1 is 1, so 4 times 1 is 4, so the result is 4. The point 2, 4 lies on the curve, whose gradient is given by dy by dx equal minus 2x plus 1. So find the equation of the curve, which is y. So y, to get y we can just integrate dy by dx. So to get y we integrate minus 2x plus 1 with respect to x. Alright, so we integrate dy by dx. So which means y, integrate this, we get minus 2x squared over 2. Integrate 1, we get 1x plus a constant. So this is y equal 2 into 2, that's minus 1, so minus 1x squared plus 1x plus c. And we are told the point passes through 2, 4. So we substitute 2, 4. So we substitute 2, 4. Alright, 2 for the x, 4 for the y. So 4 for the y, 2 for the x, so that's minus 2 squared, which is minus 4. Plus, replacing x with 2. Plus c. So if we do some transposing here, so c would be equal to 4 plus 4 minus 2, that's 6, so c would be equal to 6. So therefore, equation of the curve is y equal to minus x squared plus x plus 6. Next, we are asked to calculate the area under the curve in the finite region in the first quadrant between 0 and 3 on the x-axis. So the area would be the integral of y dx between the limits 0 and 3. So the area, remember the y was, remember we found the y to be, y was what? Minus x squared plus x plus 6 dx between 0 and 3. So we integrate. So we end up with minus, add 1 to the power, that's minus x cubed over 3, whatever it was, plus x squared over 2, plus 6x for the limits 0 and 3. So let me continue over here. Let's continue question over here. So A, so we form 2 brackets. In one bracket you plug, in one bracket for the x, we replace the x with 3, and in the other bracket, replace the x with 0. Replace x with 0, everything becomes 0 in the second bracket, right? So the first bracket, replace x with the top number 3, so it's minus 3 cubed. So it's minus 3 cubed over 3 plus 3 squared over 2 plus 6 times 3. This becomes now negative 3 squared, so that's negative 27. Well, 3 cubed, negative 27 divided by 3, that's negative 9. Plus 3 squared, that's 9 over 2. Plus 6 times 3, 18 minus 0. So the area is, this becomes now negative 9 plus 18, that's positive 9. And 9 9 plus 4.5. That's what? That's 13.5. That's 13.5. It's area, so square units. Next, so this was back in the day when we have options. So here, in this section, you're given two questions. I think one is statistics and one is mechanics, and you're asked to answer only one. But we're going to answer both of them. So I'm going to begin with question 7, which is a statistics. So we have a stem and leaf plot here. So we're asked to state the number of students in the class. The number of students in the class. So we can add up the number of boys and add up the number of girls. So how many girls do we have on the right hand side here? So each digit represents a number, a different number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there seem to be 14 boys. Add up the girls now, the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Seem to be 14 girls. 14 girls. And 15 boys. So 14 and 15, that's 29. So there's 29 students in the class. Construct a box and a whisker plot for the entire grade 5 class, boys and girls combined. Alright, so let's do this. So, of course, so we have stem. And in the leaf section would have boys and girls combined. Alright, so if we look at the data, alright, so stem, so 2, and then now 8, 8, and then another 8, and 2 9s, right? If we look at 3, alright, so we have 2, 2, 3, there's another 3 over here on the boys' side. And then we have 5. And then we have a 7. And then we have 3 8s. And 3 9s. So 3 8s, 3 9s, a 7, 2 3, 2 2s, and a 5. And for 4, the 40s now. The 40s we have 3 zeros. 1, 2, 3. We have how many 2s? Seem to be 2 over here. So we have 6 ones. 1, 2, 3, 4, 5, 6. We have a 2. And we have a 5. And then in the 50s now, it's just 51. So that would be the box and whisker plot for that. Sorry, the stem and leaf. We have the combined data. So this means now we can get the information needed for the box and whisker plot. So we need the smallest number, the lowest value. So the lowest value there would be 28. We need the highest value. The highest value there is 51. We need also the median. Now to get the median, so the median is, remember, it's 29 numbers. Divide 29.2. So at 1 to 29 we get 30 divided by 2. So remember the median is n plus 1 over 2. That value, right? So n is 29, at the 1 you get 30 divided by 2. So the median is the 15th number. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's this number. So the median is this is what, 39. So we need now the quartiles, specifically upper quartile and lower quartile, Q1 and Q3. So Q1, now to get the lower quartile, so this number 39 is in the middle. So we left with remove it, so we'll have what now? And 28 numbers, so 14 numbers on either side, right? So the median would be between the 7th and the 8th number. If we have 14 numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's check again, sorry. 14, so 7 and 8. So 1, 2, 3, 4, 5, 6, 7. So the median fall between these two numbers, between 32 and, sorry, the median for the lower half, the first quartile, that's 32 and 33. Divided by 2, we get 32.5. And Q3, on the right side of this line here, on the right side of the median, we also have 14. So the 7th and the 8th number after the 9 here. So 1, 2, 3, 4, 5, 6, 7, 8. So 41, the same 41 and 41 divided by 2, that's 82. Divided by 2, that's 41. So the lower quartile is 32.5. The upper quartile is. So when we're doing the box and whisker plot now, we need to show these 5 sets, 5 data points, right? So we have the whisker here. So we have the box, the box, all right, box. At the end, the smallest number, which is 28. I do it on a graph paper, of course. Next number to that would be highest number would be 51. The lower quartile, that's what? 32.5. 32.5. The upper quartile, 41. And the mid quartile or the median would be 39. I think 39 would fall closer to the 41. So it would be 39. So it's 5 data points we'll show there, and of course, you'll do it in a graph paper. Okay, next. The standard deviation for the weights of the boys is 5.53. Determine the standard deviation of the weights of the girls. Provide an interpretation of your answer for the girls compared to that given for the boys. So to find a standard deviation for the weights of the girls, we first need to find the x bar, the mean. Same thing we call x bar. So the mean weight of the girls. Now, let's go back to the numbers. Go back to the numbers for the girls. So for the girls, we're going to add up all of these numbers and divide by how many girls were there? I think there were 14 girls. So we're going to add up all of these numbers and divide by 14. Alright, let's do that. So we add in 28 plus 28. Let me just do it there. So the girl, so 28, so we had 28 was there twice, so 2 times 28, okay, 28 was there twice. And then we have a 29, and then we had 232, 232 was there twice, and we have 33, we also had 35, 38, 38 was there actually 3 times. Let's double check. So 38 was there. So for the girls, notice 38 was there 3 times. So 3 times 38 plus 40 plus 41 was there twice. and we had a 42. All of that divided by the total number of girls, which was 14. So this becomes 495. The total was 495 over 14, and that's to 2 decimal places, 35.36. So now we can calculate standard deviation. So standard deviation. So the formula for standard deviation, so standard deviation, S is equal to the square root of the summation of x minus x bar square over n. So we're going to subtract. So from each x value, we're going to subtract the mean and square the result and sum the result. So we need to create a table. Let's create a table there. What a space. Let's create a table. So we know x bar was 35.36. So I'll just delete this. I don't need that again. Some space. Let me just separate it. So we know x bar. So put it here. So the standard deviation is the summation. So let me just find x minus x bar square first. Alright, so let me just find x minus x bar, the summation of x minus x bar all square. So this is in. So for each x value, we're going to minus the mean and square the result. So we have 28. So 28 was the x value. So 28 minus, we subtract 35.36. We square the result. And remember, 28 was there twice, so we multiply that by 2. Plus the 29, we subtract 35.36. Square the result. Plus, continue down here, plus 32 minus the mean, which is 35.36. Square the result. Remember that the 32 was there twice, so times 2. Plus 33, so 33 minus 35.36. Square the result, so one of the ones. Plus 38 minus 35.36. Square the result. And 38 is there 3 times, right? So times 3 plus 40 minus 35.36. Square the result. 40 was just there once. Plus 41 minus 35.36. Square the result. 41 is there twice. Multiply by 2. Plus 42 minus 35.36. So I subtract and square the result. Alright? So let me just pause the video and calculate what all of this works out to be. Alright, so this means that this summation, so this is equal to, what's the calculator showing? 327.22. So the summation of x minus x bar square, and we'll get this by subtracting the mean from each value and square the result. So the standard deviation, the formula for standard deviation is equal to the square root of the summation of x minus x bar square all over n, which would be equal to the square root of, so 327.22, 327.22 divided by n, and remember we had 14, so n was 14. And this works out to be 4.83. So in terms of the interpretation, remember the standard, and this is for girls. This is for girls. And remember the standard deviation for boys. That standard deviation for boys was, remember, that was, what was it again? 5.53. So notice the standard deviation for girls is less. So which would simply mean that the data for the boys has a larger spread. Since the deviation, and that's what standard deviation is, the extent to which the data deviates from the mean, since the deviation of the data from the mean is lesser for the girls. All right. So all right. So that's what that is saying. Next, determine the number of students above the 20th percentile of this class. So the number of students above the 20th percentile of this class. So let's find the 20th percentile. So the 20th percentile would be 20% of the total amount. So 20% of n. How many students are in the class again? So 20% is 20 over 100, so that's 0.2 times 29. The combined amount in the class was 29. So 0.2 times 29 would give us 5.8. So we'll look for the 6. Let's look for the 6th value then. Let's look for the 6th value. Let's go back to the combined table. This was a combined table for boys and girls. So 1, 2, 3, 4, 5, 6. So the 6th value is 32. So, and this is also 32. So notice, so up to 32. So this would take up how many numbers now? 7. So 3, 5, and these 2. So 7 numbers, and remember we had 29 students, right? So 7. So above the 22, we'll end up with thing jumping all over the place. We'll end up with 22. If you count all of these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Yes, because it's 7. These 7, and then it's from 29. So with 22 numbers. Alright, so 22 persons would score above the 20th percentile. So the number of students above the 20th percentile, so number of students above the 20th percentile would be equal to 22. So part B, a vendor has 15 apples on a tree. So 5 red, 6 green, 4 yellow. A customer requests 3 apples but does not specify a color. determine the probability that the apples chosen contain one of each color. Alright, so let's look at the possibilities. Alright, so the customer can get red, green, yellow. Alright, it's probability of red, green, yellow. The customer can get red, yellow, green, or it could be it could be yellow, red, green, or it could be yellow, green, red, or it could go on 6 so far, 1, 2, 3, 4, or it could be green, red, yellow, or it could be green, yellow, red. Alright? So this the probability of containing one of each color could be these possibilities: red, green, yellow, or red, yellow, green, or yellow, red, green, or yellow, green, red, or green, red, red, yellow, or green, yellow, red. So these are all the possibilities. Alright, let's write them out one by one now. So first, so let me separate that. So P, let me do red, green, yellow. So red, green, yellow first. Red, green, yellow. Alright? So red, the probability that's what 5. So is 15 in all, right? So red is 5 over 15 times what's green? Green is 6 over 15. 15, not 16. Six over 15. Well, it's 6 over 14 because if one come out, so we assume it's without replacement. All right, we could have also used a tree diagram, but anyway, so 6 over 14 times, and if yellow come out next, it would be 4 over 13 plus, let's look at the second possibility. So if red come out first, so red 5 over 15 times green, so it will be 6 over 14. Sorry, yellow will be 4 over 14, and green 6 over 13. Each time one come out. Alright? Plus, let's go to the other one now. Yellow 4 over 15. Red 5 over 14. Green 6 over 13 plus this one now. So we're gone 1, 2, 3. So we have 3 more. So this one now. So yellow 4 over 15. Green 6 over 14. Red 5 over 15. Alright. Plus it's green then red then yellow. So green 6 over 15. And when the one come out, You're left with 14 now. So red, 5 over 14. Yellow, 4 over 13. Plus, what if it's green, then yellow, then red? So green, 6 over 15. Plus yellow, 4 over 14 times 4 over 14. Red, 5 over 13. Alright? Write this out, what we end up with now. Notice for all of them, the denominator is 120. 6 times 4 times 5. The numerator is 120, sorry. And the denominator is 15 times 14 times 13. That's 2730. And it's 6 of them, right? So we end up with what now? 0.264. Next, the probability that they are all the same color. Now, for them to be all the same color, you'd have to have the probability for all same color with the probability that you get green, 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 or probability that you get red, 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 or the probability that you get yellow, yellow, yellow. Alright? So green, green, green would be, alright, remember I was 6 greens. So on the first draw, 6 times 6 over 15. Second draw, 5 over 14. The third draw, 4 over 13. Alright? Plus, remember how many reds were there now? Reds was 5 reds. So 5 over 15 on the first. Probability on the second will be 4 over 14 since 1 come out. And for the final, 2 come out already. So 3 over 13. Plus the yellow. How many yellows were there now? 4 yellows. So 4 over 15 times 3 over 15. 3 over 14, sorry, times 2 over 13. Alright? So notice all of them have the same denominator. 15 times 14 times 13. Same denominator of 2730. And the numerator, so for the first one, 4 times 5, 20. Times 6, 120. That's 60. 5 times 4 times 3. And 4, 3, 12 times 2, 24. So the probability here becomes this one now. 204. 204 over 2730. Which would give us 0.075. Alright, so now we're moving on to the mechanics question in question 8. A car has stopped at a traffic light when the light turned green. It accelerates uniformly to a speed of 28 meters per second in 15 seconds. The car continues to travel at this speed for another 35 seconds before it has to stop 10 seconds later at another traffic light. And the grid provided, draw a speed time graph showing the information above. Calculate the distance the car traveled between the two traffic lights. Let's look at the grid. Let me just do a little sketch while I'm looking at the question. Let me do a little sketch while I can look at the question. simultaneously, alright? So sketch here. Of course, you'll do it in a graph paper. So we're doing a speed time graph, right? The speed on the y-axis, and the speed is meters per second, and time is in second. And of course time is in seconds. Alright, so where they meet here is 0. So a car stops when the light turns green. So the car is at rest. It accelerates uniformly to a speed of 28 meters per second. So it accelerates, so it's a straight line uniformly to a speed of 28 per second. It's 28 meters per second in 15 seconds. So, alright, just doing a sketch here. So in 15 seconds, it accelerates uniformly to a speed of 28 meters per second, right? The cars continue to travel at this same speed for another 35 seconds. The speed remains constant. Another 35 seconds. That's 35 and 15 now. 40, 50. So another 35 seconds. So up to the 58 second here. Your speed remains constant. Alright, so it's 3 phase, and the car continues to travel at this speed for another 35 seconds before it has to stop 10 seconds later at another traffic light. So 10 seconds later, it stops again. So after this 58 seconds, in the 68 seconds, it stops again. So that will be the sketch. Alright, so this will be answer the part 1 the sketch, and of course you'll do it in a graph paper. Calculate the distance traveled. Of course, distance traveled is area under the graph. So total distance traveled. So distance traveled would be the area under the graph. Alright. So the area, distance traveled is equal to area under the graph. And that's a trapezium, right? Area under the graph. So the distance, same thing we call D. Now the area is a trapezium. What's the formula for area of a trapezium again? Half sum of parallel sides times distance between. So it's half sum of the parallel sides. So from here to, so these are parallel 0 to 60, that's 60. And then parallel sides 15 to 50, that's 35. So in the bracket you'll end up with 95. So half of 95, and distance between these two parallel lines is 28. So half times 95 times 28 should give us 1330 meters. Next we're asked to find the average speed, and the formula for average speed, is total distance over total time, right? So total distance over total time. The total distance was 1330 meters. So it's 1330 meters. And the total time was, what's the total time? Total time was it's there 60 seconds. So 1330 divided by 60. 1330 divided by 60. That's 22.167 meter per second. But the question want the answer in kilometers per hour. So we have to convert the meter to kilometer, and convert the seconds to hours. So 22.167 meters per second. Alright, so I'm going to 22.167 meters. So to convert the meter to kilometer, I will divide the 22.167 by 1,000. So 22.167, I divide that by 1,000. And then divide by the seconds. So 1 second, I'll convert seconds to hours. How do we convert seconds to hours? Divide by what now? 3600. So this becomes, so let me do the calculation here. So 22.167 divided by 1,000 equal, and I'm dividing by 1 second. This looks like a 5. Let me just move it. Divide by 1 over 3600. So converting seconds to hours. So it would be times 3600. And end up with 79.8. So this would be 79.8 kilometers per hour. Let's move on. A particle moves in a straight line such that t seconds after passing a fixed point O, its acceleration is given by a equal 12t minus 17. Given that its speed at O at the start is 10 meters per second, determine the values of t for which the particle is stationary. So if the particle is stationary, of course, the velocity is 0, right? So we get the velocity. We get velocity by integrating acceleration. So velocity, integrate acceleration, which is 12t minus 17 with respect to t. So v, integrate 12t, we get 12t squared over 2 minus 17t plus a constant. And so this is 6t squared, 12 into 12 divided by 2, minus 17t plus c. And how can we get the value of c? Now we are told that when the time was 0, the speed was 10. Alright, speed was 10 at the start. So substitute this v is 10 when t is 0. So we end up with, replace v with 10. And everything will be 0, so c will be 10. So therefore, the velocity here would be 6t squared minus 7t plus 10. That's a function for velocity. But the question, I want the values of t for when the particle was stationary. So we're going to find the values of t that would make v 0. So let me just move this to do the problem. So therefore, let 6t squared minus 7t plus 10 equal to 0. Since we are told that the particle was stationary, we want to find the values for t when the particle is stationary. And it's stationary when v is 0, right? So stationary when v is 0. So when v is 0, the function here is equal to 0. So we can solve. And of course, we can factorize if we're using the AC method. AC here is 6 times 10, 60. So we want two numbers that multiply to give 60 and add to give minus 17. That look like minus 12 and minus 5. These two numbers add to give negative 17 in the middle term and multiply to give positive 60. So 60 squared we write as minus 12t minus 5t plus 10 equal to 0. So we factor by groups. So we have 6t, and then we factor out what now? T minus 2. In the other pair, we factor out minus 5. And we have t minus 2 equals 0. So t minus 2 is our common factor. And we have 6t minus 5 equals 0. So we equate both of these to 0. So t minus 2 equal to 0, or 6t minus 5 equal to 0. So we solve. T equal to 2. So when t is 2, the particle was stationary. Also solve this. 6t equal to 5. Divide both sides by 6. So the particle was also stationary. Divide both sides by 6. Was also stationary when t is 5 over 6. Next, we're also calculate the distance the particle travels in the 4th second. So to get the distance or displacement, alright, we'll get the displacement or distance by integrating velocity with respect to time. So we're going to integrate velocity. Velocity was what? 6t squared minus 17t plus 10. We're going to integrate this with respect to t. So integrate 6t. We get 6t squared, we get 6t cubed over 3. Add 1 to the power, divide by the power. We get 17t squared divided by the power is 2. Integrate 10. We get 10t plus a constant. Alright. So S, let's call displacement S. So we need a value for K. So we know that displacement is 0 when the time is 0. Alright. So substitute t equal to 0 when S equal to 0. So the constant there is 0. So the displacement is really, well, 3 into that's 2t cubed minus 17 over 2 t squared plus 10t. So to get the distance in the 4 second, we simply replace t with 4. So we substitute t is equal to 4. So S equal to 2 times 4 cubed minus 17 over 2 times 4 squared plus 10 times 4, and that should give us 32 meters.